Hello and welcome to another Ginger Mathematician video where I'm going to go through everything you need to know on binomial expansion for the A-Level Maths Paper 1, and by the end of this video you'll be able to master a variety of different exam questions. Now this is on the formula booklet that you have access to, so we're going to be using particularly this section of the formula booklet, so make sure you have that to hand and are ready for it. Okay, let's get started. So this is our very first question. So the coefficient of x squared. So what that means, the coefficient is the number before the x, or the letter before the x here, in the expansion of 1 plus 2 over px to the power of 5 plus 1 plus px to the power of 6 is equal to 70. And find the possible values, that's really important, of the constant p. As soon as I see possible values, I'm thinking we might get a quadratic as we go through. So I underline it just to keep that in my mind as we go later through the question. So the first thing we need to do is find the x squared term of the two expansions. So this part here and this part here. So let's start with the 1 plus 2 over p x to the power of 5. Now, if we go back to the formula booklet here, we want the x squared term. So in order to get the x squared term, we want this term to be squared. Therefore, if we go to the formula sheet, we need to look at this part of the binomial expansion. Why have I chosen this? Because the second term, the b here, is squared. So I'm just going to write that down just to remind myself what I want to do here. So n2, so that's our binomial coefficient, a n minus 2 and b squared. So in this case, we are going to take n here to be 5. So 5 minus 2, that's equal to 3. Now where's the 5 come from? This n comes from the total power for the bracket. So we can then work out then 5, 2, like so, and then a cubed because n is 5 here, and then the b squared. Now we just need to substitute in what our a and b are. So if I highlight this, this first term is going to be a. Let me just make that nice and clear. And this is going to be our b. Now we're going to do a lot of questions on this in this video, so if you're not so sure at the moment, then don't worry, we'll be getting lots and lots of practice. So what this will do then, we'll get 5, we tend to call this choose 2, so 5 choose 2, a is 1, so 1 cubed, which is going to be 1, and then b squared, so 2 over p x all squared. Now you're probably looking at this bracket thing, it looks like a vector, doesn't it? Yeah, and exactly how we work this out. Now we don't have to do this manually, this is where the calculator comes in. Now on the calculator, they tend to write this slightly differently. They tend to write this as 5 choose 2, hence this C in the middle. But notice notation, you'll see this in the formula booklet, but also in the mark schemes, they tend to use this big bracket notation, and I tend to use that on most courses as well. So what we're going to do is work out what this 5 choose 2 is by using the calculator. So make sure you've got your calculator set up. I'm going to be using the CG50 here. You've got a class whiz, actually in some ways it's easier. You're going to be looking for a yellow part on the button which has a C. So I'm going to use this calculator here. I've got this NCR selected already. If you're wondering where this comes from, you go to options, you press F6 to go to probability, and then the functions will appear. And we want to do 5 choose 2. So all we have to do here is just click on 5. We click on F3 to give us the C button, and then 2, and that will generate then 10. So we're going to be using 5 choose 2, which is 10. So all I'm going to do is wherever I see a 5 choose 2, I'm going to put a 10. 1, again, anything times by 1 just stays the same, and then we're going to get 2 over p x all squared. This is where we have to be quite careful. Remember, it's squaring the entire thing. So we get 10 times, well, 2 squared is equal to 4, p squared is just p squared, and then x squared is just x squared. And we can tidy this up slightly, so 10 times 4 is equal to 40, so we get 40 over p squared x squared. So we've managed to work out the x squared term of that first bracket, and we're going to consider, let's highlight this, we're going to be considering that coefficient a little bit later on. Now let's do exactly the same process. We're going to get some good practice here of 1 plus px to the power of 6. So we get 1 plus px to the power of 6. So let's have a look at which term that we want. Remember, we want the x squared term. So we go back to our formula sheet. We want to use the same thing in the box here as we did before. So I'm just going to write that down. So n2 a n minus 2 b squared. Okay, but this we have to be slightly careful because notice our power here is now 6. It's not 5. So then we're going to do 6 choose 2, which we'll work out in a moment. We're going to do a to the power of 4. Remember, 6 minus 2 is 4. And then b squared. So if we work this out, let's just do 6 choose 2 nice and quickly. Okay, so we just type in 6 choose 2, and that's going to generate us 15. So we can replace that with 15. Now we're going to get 1 to the power of 4, again our a term, just like we did before. Let me just highlight this again. I'll go more quickly through the subsequent questions. But yeah, this is going to be our a, this is going to be our b. So we get 1 to the power of 4, and then we're going to get this squared. So we're going to get px all squared. Now we can do a little bit of tidying up here. So 15 is fine. 1 power of 4 is just 1. P squared is just p squared, and then x squared. So we've found the x squared terms of both the first bracket and the second bracket. Okay, and now it's saying that the coefficient of x squared in the expansions added together, notice there's a plus in the middle, is equal to 70. So if we add the two parts here, so this part and this part, so we get 40 over p squared x squared, and then add together 15p squared x squared. What that's saying, that's going to be equal to 70x squared. And in order for that to be true, then that means that this plus this, the coefficients, must be equal to this. So this allows us to generate an equation to try and solve for p. So we get 40 over p squared plus 15p squared is equal to 70. And this is where the quadratics come really, really useful. I've done a video on this as well, so do check that out in the description. And we now need to solve this. So the general approach here is that we generally don't like fractions. So we don't like fractions, let's get rid of it. So what's the opposite of dividing by p squared? Well, it's times by p squared on all sides of the equation. So this cancels, give us just 40. 15p squared times p squared is 15 to the power of 4. And then 70 times p squared is just 70p squared. So we've now got an equation that we can work with. This 40 plus 15p to the power of 4 equals 70p squared. I'm just going to write it on this slide here. So 40. So we've got a little bit more space to work with this. Now at the moment, it looks like something we can't solve because we've got a quartic. But we can make this look like something that we are familiar with. Now, a general approach when you're working with cubics or you're working with quadratics or anything is make sure you get the right-hand side 0. So we're going to do that by minusing 70p squared on both sides. If we do that, I'm going to move this around slightly. So 15p to the power of 4 minus 70p squared plus 40 is equal to 0. Notice there is a common factor here as well, so we can actually divide through by 5. Again, we want to try and make this as easy to deal with as possible. We divide through by 5, 15 divided by 5 is 3, so 3p to the power of 4. And if we divide this by 5, we get 14, so 14p squared, and then plus 10 is equal to 0. Now you can go directly to actually factorising this if you're comfortable with that. If you're not so comfortable, then we can do a very quick substitution. So I'm going to let u is equal to p squared. And if I square both sides, that means then that u squared is equal to p squared all squared, which is equal to p to the power of 4. By doing this, I can then replace the p to the power of 4 with u squared. So we get 3u squared. I can replace the p squared with just u. And notice we get a quadratic that we can actually go about solving. Now, the way I generally teach this factorising technique is I set up my brackets, and we kind of work with a trial and error approach. It's usually quicker, and as you go through the A-level maths course, you're going to need these quick methods to get these easy marks. So first of all, put 3u and u, because the only way we can time something together to give us 3u squared. And now we need to decide what numbers to put in here. Well, the factors of 10 here are 1 and 10, and 2 and 5. Again, we can have negatives and positives as well. Looking at this, notice that 10 and 14 are quite close to each other, so I'm going to be tending towards the 2 and 5. And now we can have a look and see what we want to put in at this point. So with this here, seeing if there's anything that's sticking out immediately, and there isn't. Again, I'm just going to be checking signs here to make sure that we've done everything correctly. And again, this is the key technique when you're looking through this. This is not factorising correctly, so I'm looking back through my working, and the next thing I notice is that 40 divided by 5 is not 10, it's equal to 8. So I'm leaving this in the video on purpose so you can see, even if it doesn't go exactly as you expect, it doesn't factorise nicely, then the best thing you should do is go and check your working and then see if there's something you can correct. So it should actually be plus 8 here. So again, we're going to change our factors then to everything that multiplies to give us 8. That's going to be 1 and 8 and 2 and 4. Again, pluses and minuses. And at this point, yes, there is something that works. We get a minus 4 here. We get a minus 2 here. Now, how am I spotting this so quickly? Well, what I'm doing in my head here, essentially, is just multiplying the cross terms. So minus 4 times 3u is minus 12u, minus 2 times u is minus 2u, minus 12u, minus 2u is minus 14u. So we do get our correct factorization. I really encourage you to use this kind of method. It will make your work a bit easier. Now, if we solve this, well, that means then either that 3u minus 2 is equal to 0, so u is equal to 2/3, or u minus 4 is 0, so u is equal to 4. Again, we're not quite solved it at this point because remember we used a substitution, so we're going to do a back substitution at this point. That means then that p squared is equal to 2/3, and p squared is equal to 4. And now we just need to square root both sides to work out all the values of p. Remember, I mentioned this right at the start, the possible values of p. And if we do that, we get p is equal to plus minus 2, which comes from this answer. Don't forget plus minus. And we also get the plus minus the square root of the fractions. So those are our 4 answers there. P equals plus minus 2, and then P is equal to plus minus root 2 over 3. Make sure it's nice and clear for the examiner so they can see exactly where those 4 answers are. Okay, and you can check your working here, so you can see all the different steps I've gone through. Notice if you're not happy with the factorising process, you could have always used a quadratic formula as well. That is also a perfectly valid method to get to these 4 answers at the bottom, plus minus 2 and plus minus root 2 over 3. Okay, and on to the next question. So find the first 3 terms in ascending powers of x. So essentially the powers going upwards. Okay, so you start with your constant term, then your x term, then the x squared term, and then the x cubed term if appropriate. Notice we're looking for the first 3 terms, so it's going to be a constant term, an x term, and an x squared term. So let's go with 1 plus 2x to the power of 5, and this is a case of just using your formula sheet nice and carefully. So if we go back, we're going to be using this formula sheet here, and we want to go for the first 3 terms.
So we want this part here. So the a to the power of n plus n choose 1, a to the power of n minus 1b plus n choose 2, a power of n minus 2b squared. So I'm just going to copy that across, just so that we've got that there. So n choose 1, a to the power of n minus 1b. Again, there's no harm in writing extra working, particularly if you're starting out with this kind of topic. This is quite a useful thing to do. I just want 3 terms, so I don't need to write any more than that. Now remember, our a and b, let's identify that first of all. So we've got our a, which is going to be 1 here, and then b, it's going to be 2x, and then our n is going to be that total power, which is 5. So if we expand this out, we get 1 to the power of 5, that's just 1. And then we're going to get 5, choose 1, which will work out a bit later on. Again, we always get 1s essentially for these a terms, so we can kind of ignore them, because 1 to the power of anything is just 1. So we're going to get b first of all, which is 2x, and then we're going to have 5, choose 2. Again, the a term is just going to stay as 1, and then we get 2x all squared. Now this is really important, making sure you're squaring the entire 2x term. At this point, we just need to work out 5 choose 1 and 5 choose 2. We could use the formula from the formula sheet, but let's get used to using that calculator. Okay, well, we already worked out 5 choose 2 from the previous question, but let's just work out quickly. 5 choose 1. This is going to be equal to 5. So we've got 5 and 10 for those two binomial coefficients. So we get 1 plus, well, 5 times 2 is just 10, so we get 10x. And 5 choose 2 is equal to 10, so we get 10 times, now this is where we have to be really careful, when the squared applies to both, so we get 2 squared x squared, and then this becomes 1 plus 10x plus 40x squared, like so. We're going to need that a bit later on, so I'm just going to underline it so we've got that for later. And now we're going to do exactly the same process for this one here. So we've got 1 minus 3x. Be careful of that minus, one thing to watch out for. Notice we've got a new power here to the power of 4. Hopefully getting the hang of this as we're going along. So first of all, we're going to have 1 to the power of 4. It's going to be really easy to work out. Now we're going to have 4 choose 1. So using that power here, 4 choose 1. 1 to the power of 3, and then b, which is just minus 3x. And then we've got 4 choose 2, 1 squared. Again, don't need to put that in. And this is where we have to be really careful, minus 3x all squared. That's really important. So in order to work out the next part, we just need to work out 4 choose 1 and 4 choose 2. So we get 1. Now 4 choose 1 is just equal to 4. You can check that on your calculator. 4 times minus 3 is minus 12. So let's move the plus there and pop in minus 12x. And now if we just do 4 choose 2, so I've got the calculator here. So we go 4 choose is equal to 6. So we're going to get 6. Now 1 doesn't really change anything. Minus 3 squared is actually really careful. So minus 3 squared is equal to 9, and then we get x squared. So that's going to become 1 minus 12x plus 54x squared. The biggest mistakes that are going to be made in this kind of question is that very last term and making sure that's 54x squared. Okay, that's the thing to watch out for when you're doing these questions. Now, very typical is part C, which is this word hence, which often gets ignored, and it's something to really be aware of. If they use hence, you need to use parts A and B. So you need to be using what you've already done. Because if you look at this question just separately, and you go find the coefficient of x squared of these two brackets multiplied, you go, oh god, okay, what's going on here? But if we're using A and B, we've already expanded these two. Notice 1 plus 2x to the power of 5, the first bracket, and then we've got 1 minus 3x to the power of 4, the second bracket. So all I'm going to do is replace those brackets with our estimates that we worked out from parts A and B. So I'm going to write down, we've got the first bracket, so 1 plus 10x plus 40x x squared. It's dot dot dot, but we don't really mind about that part. And then 1 minus 12x plus 54x squared plus dot dot dot. And now we need to consider how can we actually generate the x squared terms. Well, there's only so many ways that we can do this, and I'll do this in a different colour. First of all, it's going to be the 54x squared times the constant, so 1. So those two will generate an x squared term. These two will generate an x squared term for the same reason, because you get x squared times a constant, still an x squared term. But don't forget also this term in the middle, because 10x times minus 12x will give you an x squared term as well. And those are the only ways you can generate x squared terms. Notice if we had an x cubed term, that can never generate an x squared term, or generate one less than its power. So all we need to do is work out these three that I've put here in blue. So we've got 54x squared times 1, well that's just 54x squared. And then we've got 1 in the middle, so 40x squared times 1, well that's just 40x squared. And then we've got 10 times minus 12, so it's going to give us minus 120 x squared. And if we collect up the like terms here, we've got 94 minus 120, and that's going to be equal to minus 26 x squared. So our actual answer here, the coefficient, because that's what it's asking for here, is just equal to this number that we just worked out. So got our answer there of minus 26. Notice this is a 2-mark question, so it shouldn't be anything too difficult in order to work out the answer. Okay, so you can check your working there. That's a fairly on the easier side with binomial expansion. We'll go through lots of different questions in this particular video. Right, on we go to question 3. It looks scary when you see this. You go, oh God, what do I need to do? But don't worry, just take it not one step at a time and you'll be absolutely fine. So the coefficient of x to the power of 4, again, important to underline this, of this bracket is a, and the coefficient of x squared in the expansion of that bracket is equal to b. Okay, and we need to work out a and b in terms of k, okay, because we have k in both. So if we take the nth term formula, we want x to the power of 4. This is going to be a bit trickier because we've got an x squared term here and we've got an x term here. So what I'm going to do, just to sort of show you the process, because we're going to be using this idea a bit later on, is I'm just going to expand this normally without really considering that part for the moment, and then we're going to come back to it. So if we approach this in the same way, first of all we just get the first term, which is our 2x squared to the power of 5. Then we're going to have 5 choose 1, and then we've got 1 less on that index, so 2x squared to the power of 4 multiplied by k squared over x. So before I do any more expansion here, I just want to talk about the first few steps. Notice this here is going to give me an x to the power of 10 term of some kind, because x squared to the power of 5 is x to the power of 10. This term here, this 5 choose 1, well this is to the power of 8, this is dividing by x, and x to the power of 8 divided by x is equal to x to the power of 7. So this gives me an x to the power of 7 term. And we want x to the power of 4. So if we do the next one here, so we go 5 choose 2, 2x squared to the power of 3, k squared over x squared. If we consider this term now, we have x squared to the power of 3, that's x to the power of 6. This one here is then going to be over x squared. And if we do x to the power of 6 divided by x squared, we get x to the power of 4. So it's this term here, so I'm going to highlight, that once we expand this out, and you probably need to see this a couple of times to believe it, is going to give us the x to the power of 4 term. Now again, we've done that by a sort of trial and error method. As you go into subsequent questions, you'll see you can spot these a bit quicker. But just to give you an idea, just expand it out, because only up to 5, and then see which term actually gives you x to the power of 4. Now we need to actually work this out, so if we work out 5 choose 2, 2x squared all cubed, and then times k squared over x all squared. Now 5 choose 2 we already worked out that was equal to 10, so we can pop that in. So 10, 2 cubed is equal to 8, k squared all to the power of 2 is equal to the power of 4, and we already worked out the x squared, what happened to the x terms, and that will be then x to the power of 4, which is what we wanted. If we simplify this, then we're just going to get ourselves 80 k to the power of 4, x to the power of 4, and we're told in the question this coefficient here, 80k to the power of 4, is equal to a. So let's just write that down very clearly for the examiner. A is equal to 80k to the power of 4. Now b we can do in a very, very similar way. We can speed this process up slightly. Let me just show you how we can do that. So this is the expansion that we want to focus on. We want the x squared term. Well, the very first term will be x to the power of 4. The next term will be x to the power of 3 because you reduce one down. And so the third term will be x to the power of 2. So we can kind of cheat here and go straight to this term, 4 choose 2. We go 2kx to the power of 2 because 4 minus 2 is 2, and that's what we wanted, and then multiplied by minus 1 to the power of 2. So this is the quick way of doing the process rather than that longer way which I showed you in the previous part. Now 4 choose 2 I've still got on my calculator from the previous question, so that's equal to 6. So you've got 6 times, well, 2k all squared, that's just going to be 4k squared. Minus 1 squared is just 1, so that's nice. And then we get the x squared that we wanted. So that's going to simplify down then to 24k squared, x squared. And the question, they say that this coefficient is equal to b. Therefore, let's make it nice and clear for the examiner. B is equal to 24k squared. And that gives us our 3 marks here. Now, very typical, there's always a follow-up question to this general expansion. Given that a plus b is equal to 216, find the possible values. Again, I see values, I'm thinking quadratics and cubics to solve this. Now, we know what a and b are because we just worked this out. So a is 80k to the power of 4. B is 24k squared, and that's equal to 216. Right, so again, solving this, again, we want to make the right-hand side 0. So we're just going to minus 216 from both sides. At the moment, this looks like a fairly complicated quadratic to deal with, or quartic to deal with. The first thing that comes to mind is trying to simplify this down. And we can do this by dividing by 8 on both sides. If we can find any process that makes it a little easier for us, we should try and take it. So we divide everything by 8 here, we get 10k to the power of 4 plus 3k squared, and dividing that was 27 is equal to 0. Now, I showed you by substitution last time how to do this. I'll do it by substitution again here. So we're going to do let u equal k squared. Remember that trick that we did in the previous question? Start seeing patterns with this kind of video. Therefore, u squared will be equal to k squared all squared, which is equal to k to the power of 4. Pop this in, we then get a quadratic we can work with. 10u squared plus 3u minus 27 is equal to 0. Again, at this point, there are a few choices that we can actually put inside our brackets. So again, we look to try and factorize if we can. Let's have a think about this. So 27, its factors, got 27 and 1. We've got 3 and 9. I don't think anything else goes there. So generally, my strategy here is just try something out. So we're going to do 5u and 2u. See if we can make 3 from 9 and 3. 15, 18. Yes, we can. So if we put, and we want positive, so that's 9 there and minus 3. Again, what I'm doing in my head is essentially I'm checking these cross terms. 5u times minus 3 is minus 15u. 9 times 2u is equal to 18u. minus 15u plus 18u is plus 3u. Yes, we've got what we wanted. If you're wondering why I chose 5u, 2u straight away, from experience, they generally do choose numbers quite close to each other. Like 10u and u, that comes up less often than you think. So again, this just comes from experience. The more questions you do on this, the easier it gets. Now at this point, we just need to solve this. So therefore, 2u minus 3 is equal to 0. So u is equal to 3 over 2. Or 5u plus 9 is 0. Therefore, u is equal to minus 9 over 5. However, remember, you need to back substitute here. So we're now replacing the u back with k squared. So we get k squared is equal to 3 over 2. Or k squared is equal to minus 9 over 5. So if we try and square root this second one here, then that's not going to work. We get complex numbers. Again, so this one doesn't work. So our only answer here is going to be plus minus square root of 3 over 2. So this one in particular has only got 2 answers. So you can check all the working that I've done there. I did take this approach here of simplifying down and factorizing. I think that was an easier way to go than try and head straight into the quadratic formula, which is not always the most fun thing to do in the world. Okay, and on to the next question here. So the coefficient of x to the power of 4 in this expansion is equal to the coefficient of x squared in the expansion of the other bracket, and find a. Very, very typical, this whole equating two coefficients. We haven't seen this yet in this video, but it does come up quite often. So let's try and speed up the process going through this. Now you've seen a lot of the theory. So 3 plus x to the power of 5 here. And we want to find the x to the power of 4 term. Right. So in order to find the x to the power of 4 term, we want this to then be 5 choose 4, because that's going to make this term x to the power of 4. If you go right back to the formula, what I'm doing here is I'm matching this here with this number here. So that's how I'm matching up the binomial coefficient with the actual power. So I go right forward through, there we are. So we've got 5 choose 4, x power of 4, and because this is 4, this one has to have a power of 1. 1 plus 4 is equal to 5. So if we work this out, so let's work out 5 choose 4 in the calculator. So 5 choose 4, that's equal to 5. So we get 5 times 3 times x to the power of 4, and that gives us 15 x to the power of 4. Okay, we'll come back to that in a moment. And now we need to do this one here. So now we've got the coefficient of x squared in this expansion. Okay, now this is a bit more complicated because we've got an x term here and an x term here as well. So let me just try one out. So if I was to do, for example, 6 choose 2. I'm not saying it's the right answer, but I'm going to do 6 choose 2. Then that means then this one here has to be a over x all squared. And that means that this has to be to the power of 4. And then we get x to the power of 4 divided by x to the power of 2 gives us x to the power of 2. Great, that's exactly what we wanted. Again, this is the kind of process you can do. If you didn't get that straight away and try 6 choose 4, for example, you get the wrong answer, but then you need to learn from it. Now, if we work this out then, 6 choose 2, that's equal to 15. So we get 15. 2 to the power of 4 is equal to 16. A squared is just a squared, so that's fine. We can leave that as it is. And then we check the powers here already. Yep. So x to the power of 4. This is going to be divided by x to the power of 2, and that gives you x to the power of 2, which we wanted. So this gives you this here, and then 15 times 16 is 240, so we get 240 a squared x squared. And the question says that the coefficients, so remember the coefficients here, that's the 15 and the 240 a squared are equal to each other. Therefore, we can just say here that 240 a squared is equal to 15. And this is now just a straightforward quadratic to solve here. So we're going to get the a on its own, excuse me, by dividing by 240 on both sides. This cancels, giving us a squared. Now 15 divided by 240, aha, that's equal to 1 over 16, that's a very good sign. And now we're going to square root both sides, it's the opposite of squaring. This cancels, we get a, and then we get plus minus the square root of 1 over 16. And if we do that, you can just do that on your calculator, you're going to get yourself plus minus 1 over 4. However, you need to read the question carefully. We want the value of the positive constant a, so therefore our final answer will just be equal to a quarter. Again, you need to make sure you're reading the question really carefully so you're not missing out on every single mark on this kind of question. Right, you can check your answers there and look through everything that I've just done. And on to the next question. Again, this is the way to really get good at a particular topic, just practicing lots of questions, listening to my voice as I go through these questions, and trying them yourselves as we go through. So, the coefficient of x cubed in the expansion of p plus 1 over px to the power of 4 is 144. Find the possible values again. Again, I'm always looking for that. Of the constant p. Right, so let's open up p plus 1 over px to the power of 4. And we want the x cubed term. Therefore, I'm sort of working backwards here. So I want this to be cubed. If that's cubed, then we want to use 4 choose 3. And if we want 4 choose 3, then this needs to be p to the power of 1. So it's a way of working backwards. I know I want the x cubed term, then I know what the binomial coefficient is, and I know what this term here is as well. Okay, so 4 choose 3, we can work that out very quickly. Again, using our calculator, that gives us 4. So we get 4 times p times 1 over p all cubed, that's just going to be 1 over p cubed, excuse me, times x cubed. If we simplify this down, we're going to get some cancellation here. So we get 4 over p squared x cubed if we simplify this down. And this coefficient that we worked out, remember, p is just a constant here, it's just a numerical value. That's going to be equal to 144 in the question. Therefore, we can just say that 4 over p squared is equal to 144. And this is now just an equation to solve here. So we get 4 is equal to 144 p squared. P squared is equal to 4 divided by 144. So if we pop that into the calculator, yep, we get something very nice. Again, if I'm getting 1 over 36, I know it's going to square root really nicely, so I'm probably on the right lines. And therefore p, if we square root both sides, is going to be the square root of 1 over 36. And that's going to give us, you can check on your calculator here, plus minus 1 over 6. Notice in this question, compared to the previous one, they just want the constant p, so they haven't said the positive or the negative. So you do need to give both plus and minus when it doesn't say anything specifically. So that was a nice question. Again, a question 1, typical starter question for a paper 1, and you can check all the working there as well. And on to our next question. So we're going to find the coefficients of x squared and x cubed in the following expansion. Right, so we've got 2 minus x to the power of 6. Again, we can go specifically into these ones. So we're looking for x squared. Then we know that term there needs to be squared. Therefore, this needs to be 6 choose 2. This needs to match. And that gives you 2 to the power of 4. And then likewise, we've got minus x to the power of 3. That matches with 6 choose 3. That gives you 2 to the power of 3. 3 plus 3 is 6. Okay, so if we work this out then, 6 choose 2. I think I've already worked out 6 choose 2 in this video already. So we get 15 times 2 to the power of 4. That's equal to 16 minus x all squared. This is going to be x squared 6 choose 3, so 6 choose 3 is 20. So we get 20 times 8 times minus x cubed. Notice a cubic, it's still going to be a minus there. And that gives us then minus 160 x cubed for that one. And then 16 times 15, which I think we did that calculation before. Yeah, it gives us 240x squared. So just going to highlight our coefficients here. So 240 there, and then minus 160 there. Perfect. And hence, again, that word hence again. So using part A. So using part A. That's really important. Find the x cubed term in this expansion. Now notice we've just been working with this one here. So 2 minus x to the power of 6. So I'm just going to replace it with the two terms that we have. So we get 3x plus 1. And we have some other terms. That's why I'm putting a dot, dot, dot. But then we've got the 240x squared. To use hence, you have to be using what you've already worked with. And we want to work out the x cubed term. So the only way we can generate an x cubed term is by multiplying this one by this one and this one by this one. So if we do that, we're going to get 240 times 3. That's going to give us an x cubed term, and then minus 160. And if we work this out, I think we get 720 minus 160. That then gives us 560 for the 2 marks. Again, so another fairly straightforward question, but the key thing to realise in that particular question there is that you need to be using part A to help you with part B. You don't want to be writing out all the expansion and then realising, I could just have used part A. So please do save yourself time in the exam. Right, and our very last question here. So we're going to find the coefficient of 1 over x squared in the expansion of this. Right, so hope you're getting the hang of this at this point. So you get 3x squared to the power of 7. Okay, so again, I just want to show you an example and then see if we can work it out from there. So if I do 7 choose 3, for example, which I think is incorrect, but I just want to use this as an example, then we get this here as 2 over 3x squared to the power of 3, because these need to match, this one and this one. And then this one here is 3x to the power of 4. Actually, I think it actually does work. Again, I'm not just choosing the random answer here, but I just want to show you the thought process. If we look at the powers here, this gives you x to the power of 4. This here gives you, well, x squared in the bottom, all cubes, gives you x to the power of minus 6, or x to the power of 6, we divide it. And then x to the power of 4 divided by x to the power of 6 is equal to x to the power of minus 2, which means we do get what we're looking for down in the denominator. So we do actually generate what we wanted, which is good. Again, you try 7 choose 4, we won't get the right answer, but then you just need to modify it slightly. Now 7 choose 3 we haven't done so far. So that's equal to 35. We have 3 to the power of 4, that's 81. Again, you can do this on your calculator. Here it gets a bit more complicated. So 2 cubed, that's equal to 8. 3 cubed at the bottom, that's equal to 27. And we decided that we do get the 1 over x squared that we're looking for. Now at this point, we really do want to look for simplification. We can, of course, put this all into our calculator. So we've got 27 goes in 27 once. 27 into 81 goes 3. Okay, so then we get 35 times 24 times 1 over x squared. And if we work this out on the calculator, 35 times 24, that's equal to 840 times 1 over x squared. So our coefficient here, which is what we're looking for, so I'm just going to write this really clearly, is equal to 840 for all 4 marks. So you can check through the mark scheme here and have a look through. And if you really want to get up to speed on all things paper 1 specifically, so if you want to revise that before the exams, then check out the video in front of you, because I do go through some binomial expansion, but the other 9 key topics you need to know to get those very top grades at A-level maths.